Hello, everybody. Good afternoon, and excited to tell you about a new project which has been started by Certora. Please take a look, and we'd like you to contribute. This is a joint work. This is a joint work with John Thoman, who will be here later. So many of you know that the smart contract is a very, very hard to get right. And we know it's a domain with hero developers, and a lot of bugs are there. But the question that everybody asks, and we see it all the time, and actually we have seen it yesterday, is that what's going on with LLM? So how many of you heard about the Pashov tweet about the LLM hack? Can you tell me? Sounds like nobody. It's very interesting. Take a look. Basically what happened, LLM generated a bug, and this bug actually caused people to lose a lot of money. And the purpose of this talk is to show that this can be avoided. So what we're going to show something which is a little bit counterintuitive. We're going to show that, in fact, with LLM, we can make the code more secure, not less secure. And our secret sauce is formal verification. The idea is that we can generate a code which is formally verified. So we're going to basically make a code which is generated and is formally verified. So the problem of LLM-generated wrong code is not unique to Web3. So how many of you heard about Cloudflare? Nobody? Okay, at least some people heard about. So Cloudflare is a reputable Web2 company. And what they did, they had a very beautiful blog post. Take a look. And this blog post say how they generated one of the most interesting distributed protocol in one day. Guess what? This was completely broken. Okay? And basically LLM generated all these buggy code. And this is actually something that we're going to see more and more, that LLM generated buggy code. And of course, also code that is not generated by LLM is buggy. So the Cloudflare Workers project, I really recommend that you take a look, is something that is basically was generated overnight by engineer. Very, very nice idea. But what happened, it was completely broken. And you can take a look into the code here. I hope you can see. Can you see from here? Can you see what's wrong in this code, actually? Very easy to see in this case. Do you see? I mean, this code is huge. I just took the small code. Did you see what's wrong here? Basically, the LLM completely cheated. The LLM basically put it to do on all the complex parts, okay? And the engineer, I don't know, he wanted to ship the code early. So basically, this is code. And in fact, Cloudflare apologized, all is okay. So LLM generate wrong code. And there's actually two problems why LLM generated new code. It's not just you want to go to ChatGPT 5 or ChatGPT 6. It's going to be remaining. And the idea is that there are two problems of the LLM. That it's one of them is basically the idea is that LLM really doesn't know what you are building. So it just has a guess. And the other one is that, and this is specifically to program, that it glances over corner cases. It really doesn't understand some corner cases of the code. And related to that, there are actually two problems that are really, really specific that we see, that the LLM is always making some unjustified assumption. And I'm going to show you. This has happened in the Cloudflare in many cases. This will happen in your smart contract. It's making unjustified assumptions. And the other one, which is very specific to the code, the LLM is doing some kind of pattern matching, which is visual. But in fact, when we are talking about program, they have semantic behavior. They have something very, very different. So here is a very, very tiny example. There is a code which is generated by LLM, and it is wrong. Can somebody guess what's wrong here? It's a very, very simple code, and the LLM generated the wrong code. Okay? Does anybody see something? This is a verifying of signature. Maybe I give you a guess. What does this function return? Can you tell me? So this function returns always true. It's completely broken function, okay? And the LLM generated a completely broken function here, okay? And that's very interesting. That's very interesting that the LLM, even in this small code, it generates this wrong code. So the idea of unjustified assumption is very, very interesting. And it's a very interesting thing because when we talk to people with LLM, they tell you, oh, the problem is the fact that you don't have enough memory. But in fact, the problem is kind of weird. If you don't have enough memory, then you don't have enough context, it will get wrong. If you have memory, then it will get a lot of context, it will also get wrong because it will be confused by this other context, okay? So let's make it like an art somehow. That's the idea. And you take a look, it's very interesting. You increase the context, you reduce the context, still you get a wrong code. So the other bias is the pattern. The LLM does, which is the right thing kind of, it looks into the pattern. And it looks into the pattern and it says, what is it that is going on? So you see this verify and he's trying to see what is this verify. And he's actually looking at it and does this pattern matching. And based on this pattern matching, it says what is the correct code. And in fact, it's interesting. Many of us as humans, we do the same thing. We also do pattern matching. We look at it and say, oh, this is verified, this is true, it returns true. So in a sense, we do the same thing as human. So this is what we do. So this is a bad problem. And in fact, everybody's going to use LLM. And I'm not telling you from this talk that you should not use LLM. I'm only telling you that you should use LLM with caution, okay? So what you can do, how can you prevent these bugs? How can you prevent the bugs that are generated by LLM? So there are many ways you can do it. And the first one, which is the obvious, but it's still not so easy to implement, is with the appropriate prompt. If you know how to prompt, even this bug, you can avoid by telling the LLM not to bullshit you. Okay, you can tell the LLM, tell me why this function is returning this thing. And in fact, it will notice that this function is returning a Boolean and it will not return true. So it's understand it, but you have to prompt it to the right thing. Okay? The other thing that you have to do, you have to develop some kind of hacker mindset. When you are working with LLM, you have to assume that this can get wrong. So you have to somehow have like some kind of an auditor mindset. And if you are an auditor mindset, you can find these bugs. That's the second thing. And of course, you can also get external review or audit, which are doing similar things. What in this talk we're going to show you, that we have technology that can essentially find these corner cases for you. So you can use fuzzing, you can use static analysis. We use formal verification. The idea is that with formal verification, we can eliminate these kind of bugs. Okay. So we built this tool called AI Composer. It's composed. It's basically, it combines LLM and formal verification. And you can get the best of both worlds because you don't need to fully understand formal verification and you avoid the bugs which are generated by LLM. They both feed each other. So this is how normally, maybe I can take this out. This is how normally you work with LLM. You see you have a loop and you basically ask the LLM to write the code. The LLM, if you are careful, you find it and you get it wrong. And then you iterate. You iterate until you get it right or until you are satisfied by the result. With AI Composer, the situation is a bit more interesting in the sense that we save you a lot of time and we get you more correct code. So we ask the LLM not just to infer the code, we also ask the LLM to infer the intended specification. So instead of doing one thing, the LLM does two things. But in fact, it does them better. So it infers the program and the specification, and then we run it by a sequence of methods. We start with static analysis, fuzzing, everything. At the end, we have this formal verification that actually checks that the code obeys the specification. And of course, the human needs to know that the specification is right. But I can show you that during this process, we find bugs in the code, and we also find bugs in the specification. Okay? Because in this process, we refine. And of course, at the end of the day, you as a developer, you have to review. But you have now, I'm telling you not just what the code, I'm telling what is intended to implement. So AI Composer generates many things. At the moment, it's open source software. We try it on small code. Let me show you here is a very simple example. This is a stable coin from Circle. We wanted to generate the code by Circle. But in fact, it's very easy because the LLM will cheat. The LLM will just take the code by Circle. So we made it so it doesn't generate the code by Circle. We added the requirement of KYC. So basically, the LLM cannot cheat. And you see, actually, we wrote all these documents. Basically, it's a 100 lines that explain what it's doing. So there is this document, there is design document. We feed this design document to the LLM, and the LLM generated rules in our language. It doesn't matter, but there's parametric. There are all these things that it generates. It generates these rules, and this rule actually capture the essence of this protocol. It's pretty interesting, okay? And these are the rules that it generates, so it generates just formal rules of this code. And then, these formal rules, you see, we have them. We basically use that to generate the code. So now, every time the LLM generates the code, we check it. And in fact, most of the time, the LLM gets it wrong, but we fix it. We give him the example, and the LLM learn. It's very interesting. The LLM learn. Eventually, it gets the code which satisfies the specification. Sometimes it's smart enough to tell you that specification is wrong too, which is interesting. So why are we doing that? So I think that this, if you ask me, I'm probably a guy which came very late to LLM, but LLM now is actually getting standard. I don't have to convince you. And we have these AI coding agents which are coming all the time. So all of these coding agents can use our tool. And LLM is actually getting better. It's interesting that in the Certora now, LLM getting pretty decent rules. And we think of LLM, we think about LLM like that it's smart enough to generate rules. So it's like a very, very smart specification. And the formal verification is like a pedantic lawyer. So they kind of work in an opposite way. The LLM is very optimistic, and the formal is very pessimistic, and they work together. So in terms of formal, there's a lot of progress in this space, specifically progress that we made by Certora, that we actually have a lot of rules which are generated, which are now the LLM can use. Of course, there are other players in this space. There is Amazon, which has done a lot of work, including the tool Lean, which is used also in the crypto industry, MyPrivacy, which I developed in the academia and now used by Amazon. So a lot of tools are doing. So formal verification and LLM are both getting ready. So what is the takeaway from this talk? What is the takeaway from this talk? So I think basically making this LLM agent with formal verification, you can actually make them better. And I think I already wrote something in Twitter, but the idea is that you can make the LLM better with the formal verification. And there are other players in this space, I think Amazon I mentioned, but the idea is you want to make the LLM better with integrating formal verification. And again, going back to the beginning of the talk, we said that there are two reasons why the LLM get wrong. One is that there is no precise definition, and the other one is that LLM may glance on facts. And so these are two problems. And we have two solutions. For the no precise definition, we generate formal specification, which of course need to be reviewed by human, but it's much more concise than the code itself. Okay? And it's also reusable. The specification of a stable coin is usually the same. And how do we worried about corner cases? This is where formal verification is good. If you have a specification, the formal verification can find corner case for you. So this is how we combine the two things. So just to wrap, he wants to close. So I'm out of time, but I want to tell you that Certora is doing many things. Please take a look. I'm not going to explain because I'm running out of time. And just to wrap up the talk, if you want to get involved, this tool is MIT licensing. We have it. We develop it for Solidity, and we saw people from Solana adapted it from Solana. It's combined with the open source prover. So reach out to me, and we have a fantastic team around here. Reach out to the team. Thank you very much for your time. No time for question, I imagine. Okay.